So, now we have to define here electrostatic potential. So, we have done work done A to B, that we write here WAB is equal to UB minus UA. It means you have taken the charge here capital Q, which is greater than 0, and here the test charge is here. This test charge is brought from A to any point B. Then the work done by external force in bringing the charge from A to B is equal to, given by this, the difference between the electrostatic potential energy of the charge at point A and the charge at point B. Now, if you are taking here the work done required to move the charge from point A to B, to move the unit positive charge from the point A to B. So, we can write here, that is a potential difference between B and A, that is delta V, can be written VB minus VA is equal to UB minus UA divided by Q. That can be written also WAB upon Q. Thus, we can say potential difference between any 2 points in the electrostatic field is defined as the work done required to move a unit positive charge from one point to another, like from point A to from point B here. So, we can write here VBA, that is a VB minus VA, that is a potential difference between 2 points A and B. Now, if you are taking the point A, suppose at infinity, then we can write here, if the point A, that is infinity, then we can write here VB minus 0, because at infinity potential is 0. So, we can also write here V at infinite here is equal to here UB minus U infinite upon here this Q. U infinite also is 0. So, we can take here VB is equal to UB upon Q. So, and also can be written W infinity to B upon Q here, and if you are taking here Q is equal to 1 coulomb, that is the unit positive charge, then we can write VB is equal to W infinity to B here. That means electrostatic potential at any point in the electric field is defined as the work done required to move unit positive charge from infinity to that point. So, that is actually electrostatic potential. So, if you are bringing the charge from infinity to the point B, then you are taking the potential at point B, and when you are bringing the charge from A to B in the electric field, then we take the potential difference between the 2 points. At infinity, we assume electrostatic potential is 0. Now, see a unit of the potential difference. We just we can write here VB minus VA is equal to WAB upon Q. If here we are taking here WAB is equal to 1 joule and Q is equal to 1 coulomb, then we can write VB minus VA is equal to 1 joule upon 1 coulomb is equal to 1 volt. So, SI unit of potential difference is volt here, and now here we can also get the dimensional formula of the potential difference. We know the dimensional formula of the work done is ml raised to power 2 t raised to power minus 2 divided by Q can be written A and T. A is representing here ampere and T is time here. So, now we can write m, and here L square A raised to power minus 1 and T raised to power minus 3. So, this is the dimensional formula of potential difference. So, now see here electrostatic potential or potential difference is a scalar quantity.